Hello and welcome. We're really excited to have everyone here today for our weekly OCI deep dive. For those of you who may be new to our events, we're hosted on Cloud Customer Connect, which is our Oracle community forum for end users. My name is Catherine Jennings. I'm Senior Principal Product Manager with the OCI Observability team. And today we're joined by Avi Huber, Vice President, who's going to be taking us through Application Performance Monitoring. And that's enough for me. Go ahead and take it away, Avi.
Thank you, Catherine. So this presentation today is about APM and concentrating on the SLA capabilities or synthetic monitoring capabilities to enable SLA monitoring. I'll start with a quick introduction. What do we mean by SLA? This is a page from a quote from one of our documents for SaaS. It's just an example. And it says specifically, this is a public document that says that Oracle is committing, or whatever the text says here, but basically it says that we are committing for some type of availability of our application. And it says, and what availability means here. It means that the users can able to log in and access the data. It also has some list of items, what happens if we don't meet our SLA. This is one SLA, of course, a SLA service level agreement. But to have an SLA, what you actually need is first to have a metric that says, I'm monitoring my application to see if the application is available or not available. And available or not available, as we said earlier, depending on the SLA, on what available means for the specific application. Another terminology, terms that is being used is service availability, which is the calculation of this. Well, how available was my service over the last month, the last week, the last day, the last 25 minutes, whatever is relevant for the application. The SLA is the actual agreement. So with the tool to monitor SLAs, to know if you are meeting your SLA or not, you are collecting the metrics in order to calculate the service availability. Now, SLAs can be official SLAs, like we see over here. This is Oracle SaaS to Oracle SLA between Oracle to the Oracle users, to our clients. But SLAs can be completely unofficial. Even if you have an application that you run internally in your organization for some group of people, you paid a lot of money, the organization put a lot of effort and money to make the application work, and there's some expectation for the application to be available. So it may be not defined in document, but there's always some kind of expectation, some kind of an SLA that exists that you, as the owner of the application, need to be able to know, is it working or is it not working? Is it meeting the SLA or not? So in this screenshot that you see here, looking at the last month of the list of different tests that we did, which means different type of availability testing for different application or maybe different activities, and each one of them we see what percentage of the time the application was up versus the last month. This is just for us to know if we're doing better or worse, and so on. We'll get more into this later on. So now that we know what SLA is, how do we monitor SLA? The best way to monitor for SLA is using synthetic monitoring. And I'll explain why. And I'll have this through the entire presentation. I'll talk about how we in Oracle, and we mean our SaaS environment, our NetSuite environment, Fusion App, GBUs, and our internal system management of application for our own operations. We are all using this tool and this system in order to get our SLAs, to know what is the SLAs, to guarantee the SLAs for our users. So I'll use our as an example of how this is being done. So what is synthetic monitoring, and explain why is it so great for us? So synthetic monitoring means I'm simulating a real user. A real user can be actually a person. if this is an application that has a web page or some action that the user does, or it may be the real user may be a Python script because this is a B2B application. So synthetic monitoring means simulate the real user and run this or execute whatever a user would be doing all the time from different locations. So every 5 minutes, I can, if I'm my application says, let's say it's an online store, and I want to see to search for actions there. This is what application search for items. This is what the application does. So every 5 minutes, I'll run a script that log in or maybe just open the page and search through some items. Every 5 minutes, I'll run it again and again and again and again. And I'll run it even from several different locations to make sure that it's running for people in the US as well as for people in Australia, because my application is global. So I'm executing multiple, I'm executing a test from multiple vantage point, meaning multiple location. And I'm capturing the results. So if it is a browser page, I'll make sure that I don't get errors, and I'm actually maybe looking for some content within the page, making sure that I'm got all the action, all the pages looks the way I expect them to look. If it's a REST monitor that makes a REST call, maybe the only thing that I'm looking for is the HTTP status. Maybe it's a POST call, but if it's a GET, maybe I'll also need to look at the content of the response is what I'm looking for. So maybe I'll use some kind of search for some content, some portion using regular expression inside the payload that comes back to see that the test was successful or not. I'm also monitoring how long it was running, because you can say, well, it's available, but if it takes 5 minutes to each page to load, that doesn't need monitoring. So I may have also some requirement that says, oh, the response needs to be within 20 seconds. And actually, depending on the different type of monitors, as you can see on the sliders, I may be monitoring only the network using TCP ping, or maybe using some other protocols like DNS. But the standard one, or the more trivial one, browser and REST calls, will have information about how long it took to load the pages in the case of browser, in addition to how long it took to load all kind of other pages. So if you are loading an application, there's 100 different URLs that are being executed to load static content, icons, Java libraries, and so on, JavaScript libraries, and so on. All of this need to be monitored, so I can see that it all happened in time. And later on, I will actually be able to use it to solve problems if I have any. So why is that so great for SLA? I said that synthetic monitoring is the tool for SLA monitoring. Why? So number one, for SLA, obviously you want it to be reliable. You want to be always running. So the metrics, the collection always need to happen. And this is what synthetic monitoring is doing. It's running all the time. Every 5 minutes, there's a clock that's running. It's from different location. Consistent, it's also critical because the test has to be the same test. Application may change, but the test has to be the same test. So if you're running or updating your application at midnight and 5 minutes, the test that runs before midnight and the test that ran after the upgrade is the same test. You need to see that the result continues to be consistent with your requirement all the time. It's actually the Boolean result is a big thing here. I cannot say that my SLA is that I need a low CPU on the server. That's not good enough. Is it good or bad? Yes, no. Every test that I'm doing, is it good or bad? So having a Boolean result is critical. Run from different location, of course, more critical or less critical. We'll talk more about it, about where I'm running the tests from later on. Proactive, meaning, again, this update that happens at midnight, the users will not start using it until 8 a.m. next morning, but the test already running at 5 minutes after the update. So you will get there's two things here. One, you'll get alerts or you will know that something wrong with your application early. That's the proactive part of it. But actually, when you calculate SLA, you don't calculate how many times users were not able to access the system. The SLA says the system is available. So you need to know that it's available even if nobody is trying to use it. And again, synthetic is the perfect way to do this. So the additional metrics like real user monitoring, infrastructure monitoring, all of these are absolutely required, but they are not enough to do SLA monitoring. So we talked about the fact what is SLA, and we talked that the way to monitor SLA is using synthetic monitoring, and we talk about what's synthetic monitoring in general. But in this case, I will talk about Oracle APM synthetic monitoring, which is part of the APM service. And I'll want to give a little bit a quick introduction, a high-level introduction to the service. So the OCI APM service right here on the top left is one of the service in the observability and management services. Right, it's a platform of several services. It includes the stack monitoring, logging analytics, database management, capacity planning, and actually several items around that. It relies on the basic telemetry available in OCI. So these all services are all native OCI services available from the OCI console using the OCI infrastructure and system and rules and security. We rely on events that are supported on the OCI level, like metric, using the metric service, the log service, and so on, using the OCI alert system. So whatever is being used elsewhere in OCI for alerting this, the use of our services, of the APM service and the other O&M services is part of it. That includes also security, how you give permission to use it, and so on. And of course, it's all running on the OCI platform itself. So the same computes and database. We actually have a lot of autonomous databases in the backend that we are using, but we are using also OKE and other services within OCI. This is within our service, how it's being used, which allow us to have actually a very cost-effective service. These services are running on OCI, but can monitor application that runs anywhere, whether they are in OCI, but also if they are running on Azure or AWS or some other cloud, or they are running on-premise, still the stuff that didn't move to OCI yet or to any other cloud. So all the services you see here on the top left here works regardless of where the application is running. So a little bit more on APM itself. So APM has actually four main components of them. The last one, synthetic monitoring, is the one that we'll talk more about. But quick review of the other legs of APM: distributed tracing, real user monitoring, and stack monitoring. Distributed tracing system. This is actually the new gen of APM services. If until I don't know, 3 years ago, 5 years ago, mostly even later, the main monitoring was done by having some smart agent running on an application. The main way to do APM was to have an agent that runs, every agent runs within the application, collects a lot of data, makes a lot of decisions, aggregate the data, and send the data to the service, or actually to some other backend that originally was not service, later on became services. But with the advance of cloud, the capacity that we can have on cloud, the faster networks, the improved security, what happens now is the services collect the agents, runs on the application. They are quite commoditized. We have our own Java agent that is very sophisticated, but there's open standards, open telemetry to have agents on any application, any language, any modern language, some of the non-so modern language as well, and send the detailed data. So every step of every transaction is being sent to the service, back to the backend, where it's all stored and being analyzed and aggregated and so on. So the service is built to accept all the space, all the traces. Trace is a transaction, and each step is a span. So all the spans of all the traces. we store it, as I said, in an autonomous database. So we actually have really good tools to allow querying it. We have a special dedicated language that is strong language to look for it, dedicated for this structure of span and traces. So if you look at the screenshot here, I see a list of transaction, a list of traces, and each one of them may be looking like the screenshot on the bottom, where you see these are each one of the steps that happen. So the steps can be actions on the front-end application, going into some function here in function as a service, going into some other other microservice or a different tier of the application, calling to a database and so on. The other part of this is the real user monitoring. So real user monitoring actually using tracing as well. Just the collection happens on the browser. So there's an agent for Java, an agent for Python, an agent for some other services in the backend. There's also an agent that runs within the browser and send data. So it just another component on the trace, but it also collects a lot of dimensions that are specific to for real user monitoring. For example, the size of the screen that the browser was running on, the version of the browser, the version of the OS, the name of the username. We get the IP address where the data is coming from, to where this user exists, where this user is sending the data from. So we can get geomap and so on. So a lot of integration, but a lot of data is being collected. And all this data is actually connected to the backend data. So when the user click on the button, we say, oh, user was running on using Firefox, ran it from New York City. At 3:55, the user clicks the OK button. 2 milliseconds later, it was executing an AJAX call. And then this AJAX call is actually connected to the monitoring of the service on the backend that says, all right, this service call was actually invoking this microservice that was calling this other microservice that was calling this JDBC call on the database. And the whole thing came back after 7 seconds and so on. So we got all of this little data and give you ability to look at this in a summarized level or in the very detailed level. An important thing here is that the last item, out of the box and customized dimensions. So I mentioned a lot of dimensions that we are collecting out of the box, but there would be dimensions that are very specific to whatever application you're monitoring. So, for example, if let's say that this is that you're monitoring an online store, you may want to add a dimension that says how much money is in the shopping cart. For every click that you do, the user do. We also collect using the simple JavaScript, collect the cost, the amount of money that are currently in the waiting for to be used. So you know the value of each transaction if they fail, if you are or searching, what percentage of transaction that had over $100 in them fail and so on. Moving on, stack monitoring. This is more of the traditional monitoring that we are familiar for many years, right? Still critical part of your monitoring. The CPU on the host, the disk space on the host. And with stack monitoring, we enable a lot of automatic monitoring or automatic discovery and a collection of for Oracle application. So if you have VBS, if you're using WebLogic, if you're using PeopleSoft or many other applications, out of the box, full instrumentation and collection for these, as well as more specific, more traditional one, monitoring app servers, monitoring the hosts themselves. We actually, if you're running an OCI, our agent is already built in the basic image in OCI, so there's nothing to do. You just flip a flag and start collecting this data with out-of-the-box dashboards and visibility and connection into alerting and so on. So that takes me back to synthetic monitoring. By the way, if there are any questions, please stop me here or let me know so I can explain if needed. Continue with the synthetic monitoring. So what we mentioned, we talked about earlier, what is synthetic monitoring, and so how is that implemented in the case of APM? In the very basic way, we are collecting, running, let's say if it's a browser type of monitor, we are collecting in the HAR file, which is the detail, the things that you can get actually in your browser. So we are actually, when you are running monitors, we are running the actual browser and collect the HAR file and have it available for you as the administrator to look later on. So if the test failed, you can look at the details and see exactly what was going through. We provide a public vantage point. Vantage point are the location in which, from which the services, the monitors are running from. So every Oracle cloud, every Oracle region, I think we have 47 right now, give or take. It's growing fast. From day one, has a vantage point that can be used. So when you're defining your, creating a monitor, you can say, I want to run this monitor from Australia, Sydney, our data center in Australia, Sydney, and also from my Montreal Montreal region, because I have customers in Australia and in Canada. That's why I would like to do that. Or maybe I want to run it from 10 different tests. I was talking about how Oracle use it. So we have actually, for different reasons, different application. One application we actually monitor. It's a big application that a lot of users are using it around the world. We are monitoring it from each one of our data centers. In addition, we actually have data centers, vantage point that are outside of Oracle that are actually deployed currently on Azure, on AWS, although we may switch this around to enable a view from outside of the network as well, outside of the Oracle network. There are also, you may want to monitor applications that are not open to the internet. In this case, we provide a vantage point that you can deploy within your OCI tenant. And lastly, we have a lighter weight agents that you can deploy anywhere. It's actually a Docker image, actually being released as we speak this week, I think, or maybe let's say this year. That you can, it's a Docker image, you can download it and run it from anywhere in the world. And we have part of our GBU businesses, we provide applications for hotels. So you can run this monitor from some window machine that runs on, under the manager desk in the remote hotel somewhere, to make sure that the network is working well and to have quick alerts on network problems to that remote location. The monitor is integrated back into tracing. So if you are using real user monitoring to monitor your application, and you are using network synthetic monitoring, the real user monitoring knows that this traffic comes from a monitor. So we can correlate the data. When you look later on the data, you can drill down from a failed test down through real user monitoring and down to the backend to see why it was failing. If it's on the server side, maybe it's a network problem, maybe it's a SQL problem, all the way downstream. The connection is there for the individual trace. Hopefully I'll show it on the demo later on. I talked a little bit about the browser monitors that we actually, the way it works is we're utilizing Selenium. It's an open source standard that you can use simple recording to record a script. So you click through the UI of the application that generates a JSON file. Now you upload the JSON file. This is the script that you want to run, and you run it all the time. So what our test does is our vantage points, they open a new, for your specific test, open a new browser and execute the script step by step as you recorded it. There are additional functionality there, like checking that the SSL is working, there's no SSL issues, there's no DNS problems. And all of these are coming together with a test to be able, again, to allow you to find problems if they are, to identify where they're coming from. Additionally, if you can see, this is a view of the HAR file that you can normally see in your own browser if you're looking with the developer tool, and see how much time I was spending loading this image that comes from somewhere, or how much time I'm spending on getting Google stuff that is being loaded to my application, whether I know it or not, and so on. Moving on, the REST monitor, similarly, we can run either a single REST call, just pinging a HTTP GET, for example, and you see in this screen, or maybe I want to use JavaScript to execute a set of calls. So I'm making one call, using JavaScript to look at the payload that came back, and based on that, making a second call to make more realistic scenario of some B2B type of applications. This is very common. We didn't mention earlier. In Oracle, we are currently running about 10 million tests every day to monitor our SaaS applications, NetSuite, GBUs, and several, quite a lot of other internal applications. So I talked about what is SLA, why synthetic monitoring, what is synthetic monitoring, why synthetic monitoring is a good way to monitor SLAs, and I explain what APM is. So now, how all of this comes together. And again, the example that I'm going to talk about is how we're doing it in Oracle. And why is that relevant to how we're doing it in Oracle? So we are covering all, we're an example of the customers. We have many customers, but Oracle, of course, is a big one for us. And we are covering everything that you would need to do, whether you're a large organization or small organization. So in Oracle, we have excuse me, about 200 internal level 0, priority 0 application, business critical application that runs internally to support our own organization. The HR system, the finance system, etc. We have another 1,200 tier 1 application. So there was 200 to tier 0, 200, another 1,200 tier 1. This is actually relevant for practically every organization. Any mid-sized organization and app will have hundreds of applications internally that need to work. Some of them more critical, some of them less critical. In Oracle, we have altogether, several thousand such applications. On top of this, we are also service provider, of course, right? OCI is a service, many services. Fusion app, all our HCR system, our and other finance system and so on, are services that need to be monitored. In this case, we are talking really large number. We have, about, let's say, give or take 10,000 instances of or customers using a Fusion app. I think I've heard that number somewhere. Another 20,000 on NetSuite, another quite many other thousands on the different GBUs, on the different specific business units. But again, we have a lot of customers that are not Oracle, that are service provider, and they are tiny comparing to Oracle. They have only 100 customers, not 10,000. But the problem is the same problem. Because if you have one application, that's a different problem. But once you go from 1 to 10, or from 10 to 100, it's the same thing, right? The 100 and 10,000 have the same problem. It's a bigger scale. Our system supports all of these. But whatever we are doing, you will have to do yourself, even if you have relatively small deployment. So where do we stand here with Oracle? As I said, high volume, right? 10 million and so on. We talked about that. And it's good to know that our services, good to know for you, I think, that we can support any number, which means we have many customers. So together, whether each customer is small or we have some customer very large, we can handle any load. And this is how we build the system, to be able to vertically increase the capacity to support any number of tests that will be required. But even if you have, so one thing is to be able to run so many tests, but to configure so many tests is also a problem, right? So you, again, if you have one application, you go through the UI and you configure it. But if you need to deploy it 100 times, you better script it. So OCI is, APM is part of OCI, and everything in OCI is available in the very same way through a CLI or Terraform or other programming, right, through APIs. And we have our group, some of the group using CLI to do the automation, others use Terraform, and the third group actually using our API with some Python script to execute. All valid and all works and all relevant to everybody. So you can create one test manually and then use CLI, any of the automation to replicate this for your different applications, instances of the same application. The other thing on the scale is important, as we serve customers from around the world, and we have customers from around the world, right? Customers that use our service from around the Synthetic service. So even if you are local to Australia, you still may need you want coverage from Australia. We have coverage in Australia. If you are local in South America, we have coverage there. So I'll cover this in a minute on the next slide. But before I go there, I want to talk about something else that is relevant for high scale. So if you are running 10 million tests a day, that means several thousands per minute. I think about 7,000 per minute, if I remember the math right. Let's say that these half of them are actually UI pages. So what are the chances that you run 7,000 pages, load pages in application in the full browser, and all of them will work fine every minute? Practically zero. You're using your own browser to go into the internet. You go into Google and you search. Every so often, it doesn't work. You get the browser is stuck. You get the error page maybe, or maybe nothing happens. You click the refresh, and sometimes you need to click to close the browser. Sometimes the refresh fix it. When the applications that are being monitored are more complex, there are more places to make errors, right? Not everybody is good as Google search. You have complex scenarios, and it gets somehow out of context and it doesn't work. So the system need to be able to work with these to identify a problem when it's a real problem and delete when it's not a real problem. So how do we do this? One of the way, there's actually several things there. There's some redundancy, try again. There's an option there when you, if the test fail, and so on. But the more practical thing is saying, well, I'm actually running it multiple times. So, for example, on the screenshot you can see here, this test is running from 8 different vantage points. So I'm running 8 different instances of the script. It's not on the screen, but let's say that I said to run it every 10 minutes. So the monitor runs every 10 minutes from 8 different locations. I'll talk about the schedule a bit later. Oops, I ran one too fast. And I'm looking at the script and I'm saying, well, only if there are more than 2 fails out of the 8, only then count this as a failure. Because if only 1 fail, it's probably not yet important. And I'm also telling you here that if there was some problem or not, don't even count this as a fail unless at least 4 tests were running. So I need to test at least 4 tests out of the 8. Typically, I will have run 8 running, but maybe someone is changing something, and I cancel some of them and making some other changes, downtimes and so on, plan downtime. So I have a rule here. This is critical rule that's being used later on to calculate your SLA. So the SLA is calculated based on this set of rules that you put on here, which is critical to make it work. It's actually almost useless if you have more than 1 or 2 applications to use synthetic monitoring without this ability in order to identify to calculate your SLA. I talked a little bit about vantage points. So this is actually what that's true for about a month ago. Again, as I said, we are available all over the world with a public vantage point. There are about 18, I think, today, and growing non-Oracle vantage points that I said that they are currently running on AWS. There are additional vantage points that you can put inside your network, as you can see here. Let's explain the diagram a bit. To monitor internal applications and eventually the on-premise vantage point that are, as I said, being released as we speak. So what do you do with all of this? This is a screenshot actually from one of our application. The monitor names are actually the end customer, our customers. I think this is one of the GBU units here, health GBU. And this is their list of customers. So this is 73 long for this specific test. And these are the results of the test. So we are looking at the last 8 hours, and you can see that these run of tests, they were all successful. This is all great. Successful is based on this rule that we said earlier, at least no more than 2 errors, or no more than 1 error. But actually, I'm not sure exactly what they are defining here. And this is one type of monitors, right? This filter page, you can select all kind of filters to allow you to add, to see more or less of your tests. They actually have a lot more tests. So we are running the test. We need to alert on them. So you may want to alert on this value, but maybe you want to have another alert on less critical values. So you may not want to use the same rule that you had for the availability for the alerts, because depending on how critical that is, you may want to get an alert when the threshold is a bit lower. So you can define a different threshold for alerts. Where the alerts goes, so internally, this is integrated with our system, but this is using the OCI service that you get alerts that can send a notification to any areas. See that I'm speaking a bit slower than expected, so I'll speed it up a little bit. I didn't mention it earlier, but security, of course, there's multiple levels of security here. One is authentication. You want to log into an application, so we can support several type of securities. This is for REST calls. For browser-based application, you may want to use multi-factor authentication. Is also supported. Using industry standard way to manage this. Obviously, there will not be a cell phone on the vantage point, but there is a service that can be used in order to generate a short period time key that is supported that is a way to monitor multi-factor authentication, to do multi-factor authentication login. A password. You need to use a password in your script in order to log into the application, but you don't want someone that I don't know, you're maybe someone who is editing your script or have access to the script to be able to see it. So the script actually can be stored in a vault. Vault is a service in OCI, and it can be our vault, or it can be your vault, you as the tenant vault. This last theme is actually interesting problem that we didn't anticipate up front. Many applications using third-party or whatever the licensing issues, how many users can be logged in at the same time? And if you run a test from 8 different locations at the same time, you end up utilizing a lot of your sessions that you are allowed to use, or maybe paying for them. So there's a way to schedule the test such that they will not run at the same time, such that you will not use too many sessions at the same time. Actually, you will see several of these example over here. So there's I can run it as a round robin, both in order to spread the test around the world over time. If I don't want to run too many at the same time, I'm paying per service, per run actually. So, or as I said earlier, stagger them such that I will not use too many sessions. That's the batch robin options. Last part of it is okay, I monitor the SLA, but what happens when I see that something goes wrong? So there's multiple levels here. One used a lot about our Oracle, among our Oracle users internally, is using custom metrics. So within the application, within the script, additional metrics are being added. So it's not just how long it took to get the whole test running, right? Let's say the test is log in, view, search for something, log out. That takes, let's say, 10 seconds. You may also want to add additional metrics in between to say how long it took to do the login. It's statistics that I want to know. I want to be able to alert on it. It's also a way, if it fails, if it takes too long, I want to know quickly where was it. That's it. So I have more metrics that I can add inside the script. Of course, the HAR file and screenshot that are being captured, actually screenshot from the browser are being captured automatically or after its steps or per command that you put into the script that says, take a screenshot right now. And all being saved, so you can look at them to see what went wrong, right? The page doesn't look the way you expected it when you do the investigation. And of course, the integration into RAM, it's a big thing, right? I'm drilling down from the script into the invocation of this specific transaction all the way to the backend. We also, if the checkbox is enabled, collect network diagnostics for a thing. So some of this application network is a big thing. And you can use the Network Data Explorer across multiple runs to see how the flow went through. So these are actually trace routes that's running for each invocation, and you can even run tests that are, this is the only thing that they are doing. So from this, I'm looking here at running from our data center in Phoenix and the data center in Zurich against this apm.omcdemo.net. This is my demo application, and I can see exactly for each one of them how long was each ping taking, where there's delay. Actually, the last entry here, this is the load balancer inside my application here. So last, kind of a quick summary of everything on APM synthetics. Number one is the high volume. Any number of monitors that you need, whether it's one monitor per hour or you need a million monitor per day, we can cover. That is important. Cover it meaning from ability to run that load and the ability to give you tools to create so many monitors and to view the result from so many monitors, right? The reporting, the alerts, and so on. Ability to use both public and private vantage points, depending on your application. You may need to do both. Something that people tend to forget. There's nothing from all the monitoring that you have in the world that will work as fast as synthetic monitoring. You want to see that your page is, you build a new application, you want to see that you can log into the application. That takes about 5 minutes. That's about 60 seconds to create a monitor, and it works. There's no overhead. There is no access that you need to get. There is no restart. There's nothing. Easiest monitoring ever that to get is to have synthetic monitoring enabled, and it can be more sophisticated to spend more time on running more sophisticated script, but the very trivial one is the easiest thing to do. It takes no time to get back. You run the test, 5 minutes later, you already have a report of 5 runs, and you know where you're standing on. Very reliable because the test is always running, and there is a built-in redundancy here because you run it for multiple locations. So whatever happens, there is a disaster in Australia and the data center goes down, it's still running from the other data center. It's also important that it works completely independently to the application. A lot of the other monitoring, let's say that you have a monitor that is monitor the CPU on your host or collect metric from the host. If the host goes down, the monitor goes down too. So you need to know, do I have a problem with the monitoring or do I actually have a problem with my host? Synthetic monitoring completely disconnected. Proactive, we talked about it earlier. You get the test before or result of alerts or see a problem before actual users are running into these problems, which is of course critical, especially when you update a new version, you want to get this test early. And the last item here is integrated with the rest of the monitoring. The rest of the monitoring is critical for diagnostics, for many other analytics and so on. You want the rest of the monitoring and you want it to be connected to your synthetic monitoring. So this is my last slide here. Obvious links that you
can I ask you a few questions?
Oh, absolutely. Let me just say one more thing, and then I'll get to the second. The Try It Now here, this is a live lab You can click on it and actually go through the entire APM. There's a script, but you can also play around in it. Doesn't require anything. Just log in, click on this, and go and do the test. Yes, I'm sorry, Dave. Go.
Well, I think just paraphrasing a few of these questions. One of them is talking about getting started with APM, right? You showed a really large rich set of features. And it sounds like you can start at a smaller level and start to build functionality on top of that and use those. Maybe you could talk to, from a developer persona, what is a good way to get started?
Sure. So actually to start, and especially with synthetic monitoring, the one thing that you need is an OCI account, and you can get them for free. Once you create an OCI account, you create an APM domain, which is a one-click button. And if you go through these videos, you will see several of 2 minutes videos instruction on how to do that, although it's pretty self-explanatory. It's important to know we have an always free version of APM. Most people will not use it to monitor their application because it's low, it's limited in scale, but it includes 10 monitor runs per hour for free. So if you want to play with this, you can do this with zero cost. Create a domain, record a script. There's a video for that as well, or just put actually, I'll show you exactly how this is done. Let me share this thing here. Do I still have time? I'm not sure.
Yeah, we have about 10 minutes.
All right. So I actually planned to do this earlier. All right, this is it. So I'll start exactly answering your question. I'm going from starting afresh. If I didn't do anything before, and I'll go to APM administration, I can create a domain here. Creating a domain, I already have in this compartment the domain. If you are a new user, you will not have anything. And if I'll create one for free, I can just do it here. You can have only one domain for free, but many pay domain. And this is about it. I click create, and about 2 minutes later, the domain exists. How do I do synthetic monitoring? Let me create a quick test. I'll select this domain that I already have. I happen to have quite a lot of monitor here, but let's ignore them. And I'll create a new monitor. Let's say I'll call it, this is test. I already created test 1, so this will be test 2. And let's say that I want to test a browser page. I'll look up a URL that I want to monitor. Let's say my APM homepage here. So
and this could be internal apps. These could be global apps. These could be any type of apps that you want to be pointing at, correct?
Absolutely. And again, depending where I want to run the test from, you will have you will decide, and I'll do it on the next step, decide where I'm running it from. So we are starting with something external. Let's say this is the APM page. Oh, you don't see it. I'm running it quickly on the new browser here. Sorry, I should have done it on the same browser. This is the URL for our oracle.com APM page, right? So this is the URL that I want to test. And let's say, let me bring it up here, right? This is our application. And just to make sure that it's loading, let's say that I'll look for, make sure that this script is showing up there. So I'll say verify content, check for this one. I want to verify the SSL to make sure it's working. I'll enable screenshot collection. And now I'm saying, when do I want to run it? So let's say that I want to run it from Phoenix and maybe also from Montreal. Oh, actually, I'll edit something here. I added internal monitoring inside my network. And I had to go through a process to deploy this, but now I can monitor with this one. I will be able to monitor something that runs inside a network too. But this is an example. I'm going outside to some external application. I want to make sure that it's being accessed from my internal network, because maybe I'm testing something that application that needs to get there, right? Third-party application. I mentioned that I have all kinds of schedule options, but let's say I want to run it every 5 minutes. And I want to enable network management for that, so I can see how the network works, configure the availability. I'll leave the default 0 and 1, and this is about it. When I click create, this is defined. So within 5 minutes, it will start running. Before we started this meeting, I defined a similar one, CCC test 1, and we can see it here. So this was running, if I'll put this on the last 6 hours, we'll see, yeah, it started just about when we started. And there's kind of a lot of metric. Put it back on 1 hour.
This is great. So this only took a few minutes to set up. You just did a live setup.
Absolutely.
And you can start small and start free at the always free tier. And then incrementally kind of grow as you do it. Kind of another angle on that question is for newer users to OCI, you may be interested in just developing or monitoring your own applications. APM, you don't need to have a big deployment of Oracle or have all the different OCI tools. APM can be used standalone, right, Avi?
Absolutely. We have customer that APM is the one and only one service that they're using in OCI. They stuff run actually on Amazon. On the AWS, the example that I'm thinking about right now. And they are running the test from here. Everything works, whether just for the monitoring, and later on, if deploying reducer monitoring or backend server monitoring, all of this will work regardless of where the application is running.
And thank you, Avi and Dave and Yutaka. This concludes our call for today. Have a great rest of your day.
Thank you.